Download this code from codegive.com, link in the description below. Batch normalization, BN, is a technique used to improve the training of deep neural networks by normalizing the inputs of each layer. It was introduced in a 2015 paper by Sergey Ioffe and szegedy and has since become a standard practice in deep learning. Here's a detailed tutorial on how batch normalization helps with optimization, along with a code example. Why use batch normalization? 1. Internal covariate shift. During training, the distribution of each layer's inputs changes as the parameters of the previous layers change. This phenomenon is known as internal covariate shift. Batch normalization helps to stabilize these distributions. 2. Faster training. By normalizing the inputs to each layer, the model can learn faster since it can use higher learning rates without the risk of divergence. 3. Regularization. Batch normalization adds a slight noise to the training process, which can act as a form of regularization. This can reduce the need for other regularization techniques like dropout. 4. Gradient flow. Normalizing the activations can help mitigate issues with vanishing/exploding gradients, thereby improving the gradient flow through the network. How does batch normalization work? Batch normalization works by normalizing the output of a layer for each mini-batch. The main steps involved are: 1. Compute the mean and variance. For each mini-batch, compute the mean and variance of the activations. 2. Normalize. Use the mean and variance to normalize the activations. 3. Scale and shift. Apply a scale, gamma, and shift, beta, transformation to allow the model to learn the optimal representation. The formula for batch normalization is as follows: backslash text bn, x, equals backslash gamma backslash frac x, backslash mu backslash sqrt backslash sigma caret 2 plus backslash epsilon plus backslash beta. Backslash. Where backslash x backslash is the input to the layer. Backslash mu backslash is the batch mean. Backslash sigma caret 2 backslash is the batch variance. Backslash epsilon backslash is a small constant to avoid division by 0. Backslash gamma backslash and backslash beta backslash are learnable parameters. Code example. We'll demonstrate batch normalization using TensorFlow and Keras. Here, we'll create a simple feed-forward neural network for the NIST digit classification task. Step 1. Import required libraries. Step 2. Load and pre-process the data. Step 3. Build the model with batch normalization. Step 4. Compile the model. Step 5. Train the model. Step 6. Evaluate the model. Conclusion. Batch normalization is a powerful technique that can greatly benefit the training of deep neural networks. By normalizing the inputs to each layer, it helps stabilize learning, allows for faster convergence, and can improve overall model performance. In the example above, we saw how to integrate batch normalization into a simple convolutional neural network using TensorFlow and Keras to classify handwritten digits from the NIST dataset. Feel free to experiment by adding more layers, changing hyperparameters, or removing batch normalization to observe its impact on training dynamics and model performance.